Hey everyone, this is another session of 100 days of coding interviews. This time it's my turn to answer a question. So, yes,
All right.
let's start. Oh yeah, so this time it's going to be a knowledge-based question, I think, so no coding.
Yeah, no coding involved here. All right, so Greg, explain to me what object-oriented programming is, or what does it entail?
Okay, so object-oriented programming is where you want to represent relationships between different items, and these relationships might be, say, one item contains multiple instances of another item, or so item A might contain many instances of item B, or item A might be a an extension of item B. So maybe, for example, if we were to use real world objects, item A might be, say, furniture, and item B might be a more specific subset of furniture. So item B might be chair, item C might be table, and these would both be extensions of the furniture object.
Okay. I'm going to list out a few keywords that are related to object-oriented programming. So I'm going to see if we can just explain what they are.
Sure.
Inheritance.
So inheritance is when so let's say there's a parent object and a child object, and I mean that in just their relationship. A child object would inherit certain properties from the parent. So, for example, let's say the parent object might have some properties such as color, size, shape, and the child object would have all of these traits plus some other ones of its own.
Okay. What about encapsulation?
I'll look that up.
Okay.
Oh, wait. So everything is contained with. Everything's contained within the object.
Okay. What benefits?
So that would be maybe different types of data plus different functions.
What benefit does encapsulation have for object-oriented programming?
So all of the encapsulated data is separated from the rest of the program. So so if something is, say, private, then the rest of the program can't access it. So only the object itself can access that data. So it prevents accidental tampering or manipulation of that data.
Got it. That's pretty good. I would add on there, like, an object that's encapsulated only cares about how to implement something, whereas other objects only see a interface to a object. So, more tightly controlled, methods that we can expose to others. and other objects don't care about how some certain thing is done as long as they're done.
So the implementation is hidden away, right? So it's more
Yeah.
of an abstraction.
Yeah, yeah. That's encapsulators, abstraction are similar to each other in that sense.
Mm-hmm. Okay.
Yep. Well, on some degrees, yeah, it's arguable. But all right, let's move on.
Yep.
What about polymorphism?
So polymorphism is so it has to do with inheritance. So say, let's go back to our previous example about the furniture. So let's say, or how about this? Let's say we have a class called shape, and extending shape are different classes. So there's so here, so shape, and then there's different classes extending it: square, triangle, circle, and each of them have a different method, get area, right?
Okay.
And depending on what the shape is, the formula for getting the area would be different. So for a square, it would be just its two sides, its width and height multiplied together. For a triangle, it's width times height divided by 2, and circle 2 pi r squared. So given a shape of, a shape S, if we were to get the area of S, well, what we would do depends on what shape is. So, what S is. So if S was actually a square, then then we'd call the method from the square class. So we have different, we have so yeah, we know something is a shape, but we can always call the get area method, but depending on what it actually is, what subclass it is, the behavior would be different.
Got it. Okay. So I see you have Java on your resume.
Oh God. Okay. Yeah.
When do you use an interface versus a inheritance in Java?
So interface.
Well, explain what those are first, and then what are scenarios
class?
Use
did
one
you say?
With the other? Yep. Let's say interface versus class inheritance.
Okay. So first of all, a class is actually so a class can be instantiated just by itself. So actually, but an interface is actually more of a set of specifications saying what functions or what methods need to be implemented. And the difference between implementing the two is with a class, so actually with a class you can actually okay, I'm actually stuck.
Okay.
Yeah.
So.
But you can't instantiate instances of an interface.
Correct.
Yeah, I don't know.
What keywords do you use to, in Java when you want to define an interface?
Implements.
Implements? Okay, and what keyword do you use
for a class inheritance, you would say a child extends a parent.
Okay. Yep. What happens if you want... What is the limitation for a class extension that interface can provide you?
So when you extend a class, some of the methods are already they can be already provided, right? So if you in a child class, if you don't define a new method, then it defaults to calling the method in the parent class. However, for interfaces, nothing's implemented. Only the specification, so only the return type of the function and the parameters of the function are defined. Nothing else is defined. So you can't. So you have to actually implement everything from scratch.
Yeah. Can I have multiple interfaces and multiple class inheritance on a single object?
In Java, I don't think you can inherit from multiple classes. However, you can inherit from but you can implement multiple interfaces.
Okay, good. So let's move on. Let's see. So let's move on into some programming patterns.
Okay. Hello? Hello? Hello?
Hello, are you there?
Yeah.
Alright, sorry, cut off.
So, programming patterns.
Yep. Have you heard of dependency injections?
So, dependency injections are when when one object hands over control to another, maybe.
Mm-hmm. And when is this useful, or why would you use it? You can just say pass.
Pass.
Pass?
Yeah.
Okay. So dependency injections are useful for running unit tests. Instead of instantiating a class within a class, instead when you construct a class that needs a reference to another class, you pass in the reference to that other class. Does that make sense?
So instead of
so if you have a car, right?
Yeah.
It's in the car constructor, instead of saying car wheel 1 equals new wheel, wheel 2 equals new wheel, you actually pass in the wheel references in the constructor. So essentially, instantiating these wheels becomes
outside
somebody else's problem.
Oh, okay. So you just pass in the instantiated objects.
Right. So what this is good for is, it's good for decoupling the code. And so they can be more modular if you want to use it in other sections. And B, for running unit tests. So if you want to test all different types of wheels on this car, you don't need to duplicate your code and recompile everything with one for each type of wheel. You can just put in a bunch of new wheels and put it into the same car class. So what other design patterns have you used or heard of?
So there's functional programming, which is for every function. Actually, so in functional programming, for any given input to a function, you're expected to get the same output every time. Hello?
Yep.
So what that means is, for example, if you have a function f and you pass in, let's say, 1, right? And you can do this 100 times and it will always return the same answer. So an example would be, let's say you have function add 1 and you can pass in, say, you can pass in the number 1 and you would always get 2 no matter what.
Mm-hmm.
So this is different from so like say in Java you have maybe something called well, basically the functions in Java can modify different I guess they can return different results depending on no matter what you pass, like even if you pass in the same thing to a function, it can return different results. For example, you can have, say, a list, right? Let's say you have an array list of something, and you have an array list, and you pass in. So you add 1, and basically, and then you say, or actually, why not? Maybe this should be like a stack. Sorry, so a stack, and you can push whatever. So let's say maybe you have a stack and you have a bunch of different elements, and so you could say stack dot pop, right? Except you would get a different result every time depending on what the state of the stack is. So this is different. So the function of programming is different in that sense. You're guaranteed to have the same result for a given input.
Okay.
And then there's also
have you used singletons before?
Singletons. No.
Okay. What about factory method? We used that a little bit during board manage.
Factory method?
Yeah.
No.
Okay.
Pass.
Alright, so let's jump on to some database questions. What's the difference between a primary key and a foreign key?
Oh, okay, so I think I know this. A primary so I guess a primary key in, let's say, so a primary key in a database would be so I guess it has to be unique, and usually they're in order. So that means every entry in the database has a corresponding key, and then the foreign key is usually used to link other data in, like, so So let's say there are two tables, right? So I'm going to start with this over. There are two tables, and one is so this is classrooms, right? So classes. So you have a bunch of classes and teachers who teaches that class. And the class has an ID. Sorry, this is class ID and teacher ID, assuming that only one teacher teaches per class. And but let's say you want to find let's say you want to know who the teacher is. So you have a different table that has the corresponding teacher ID and maybe the teacher name. And so basically, in this case, and the class ID would be 1, 2, 3, and so on. So here, class ID would be a primary key because they're in order and unique. The foreign key in this case would be the teacher ID because it actually corresponds to a different entry and another entry in a different table. But like how it's used is so let's say to find the teacher who teaches the class with ID 1, you have to find the common teacher ID in both tables and link them together to find what the teacher's name is. So that would be a foreign key.
Okay, so using that relationship, the teacher, which one, in terms of the teacher ID, which one's the primary key and which one's the foreign key?
So this one would be the foreign key.
Okay.
And this is a primary key.
Okay.
Right. No?
Oh, yeah, no, that's correct.
Oh, okay.
I think, well, depends on what your table is called for the first one, right? If it's a class table, then your classes.
Yeah.
Then your class ID is the primary key, and the teacher ID would be the foreign key. So that's correct. Yeah. So these are all table dependent, right? Depends on what you define the table as. So I think it might be helpful to say what table this is.
Okay.
Yeah. What is? Have you heard of NoSQL before?
So yeah, I know that they don't really. So their data is less structured. It's not in a table, but pass.
Okay.
How would you explain it though?
NoSQL?
Yeah.
I would say NoSQL is it's a set of flexible databases that doesn't follow, conventions of a regular relational database.
Okay.
Yeah. So NoSQL just it can be anything. It's just like some type of data storage. It can be like a graph. It can be I don't know, like JSON storage. You can store things in like columns, like 2D arrays if it needs to. The point of NoSQL is to make it flexible and easily scalable and dynamic. So like I'll populate this when I need it or something like that. Whereas relational database require every field to be populated or at least to have some instance of a null or a value. And yeah, so relational databases are built to scale up, whereas NoSQL is built to scale out. In that sense.
Okay.
What's the difference between
a relational database is built to scale up.
Up, yeah.
And NoSQL is built to scale down.
Scale out.
Scale out.
Sense. Yeah.
Okay. Okay. Yep.
What's the difference between a left join and a right join? Or what is a join in relational data, in like MySQL, for example?
So let's say if you have two tables, a left join is where you take, so let's say table A, table B. A left join is where you, or how about this? Let's start with an inner join first. So inner join, let's say you're joining them on some condition where table A dot entry ID is equal to table B entry ID, right? So you're finding so if it's an inner join, then you're looking for entries that have the same entry ID, and you're outputting those. And if there's no corresponding entry ID in table A or table B, then those aren't shown. For a left join, it's essentially the same as an inner join, except all the entries of table A are shown as well, even if there's no corresponding entry in table B.
Okay.
For a right join, it's like a left join, except this time you're including all the entries of table B, no matter if there's a corresponding entry in table A or not.
Okay. Good. All right, let's move on. What? When you're working with, okay, what is the difference between a process and a thread?
So I'm gonna have to pass on that.
Okay. So a process is, I guess, a runtime environment started by, like, say, Windows. So each program has one process, but a process can have many threads. So what threads do is they share the memory within a single process, different threads, and they run, assuming it's like one core, they run like synchronously to each other. So
asynchronously, right? Or synchronously?
I think they run synchronously to each other. So if thread 1 is running, thread 2 needs to wait for thread 1 to finish.
Okay.
Before, yeah.
So
they kind of share.
So
not
also
finish in the sense that, like, I'm waiting for you to finish, but they share the time. So the threads can't be all running at exactly the same time.
Because they all have access to the same data, and in order to ensure that there's no so to ensure that the data isn't overwritten by another thread while, say, one thread is using it, they have that implemented, right? So they actually lock. So let's say if a thread is using some data, then that data is essentially locked until the thread hands control back over to, or relinquishes control on that data, right?
I think so. I'm not too sure on that, but that sounds right.
And then you have cases where, is it called like a deadlock or something, where threads, you have threads holding onto control of some data, and they're waiting for another thread to release control or something.
I think so.
Okay.
Yeah.
I think I need to
figure
out how to explain it. Yeah. Okay.
Yeah. Okay. I'll go into some final set of questions, which have to do with web development. What are the components of a HTTP request?
So there's a header, right? Component. So it's type, I think. Header, and then there's like a get or a set. Browser, like user agent.
That goes into the header. So I'll give you a hint. There's three major lines within the HTTP request. Headers is one of them.
Get set? No, that's...
Okay, I'll just tell you.
Okay.
So body is one of them, and the first one is like method. The method, which I guess the first line includes the method, the URI, and the protocol version of the request.
The method, the URL, and the
and the protocol version. So like it would say like HTTP 1.1, right?
Yeah.
So method. So mentioned method, right? These are some verbs that the HTTP protocol uses.
So maybe
Can
get.
You name some of them?
Get. Set. Or is it get and put?
Set is not one of them.
Put.
Okay, put is another one. And can you say what those generally do?
So get is a request for data. So it's more like a read command. So a read operation. So it doesn't actually write anything to the server. Put is when you're sending something to the server with the expectation that it will do something with what you send. So maybe it might store it or something. So for example, if it was a form, it would take what you entered and store it.
Do you think of other ones? Okay.
I don't know any other ones.
Let's see. What are some other protocols that the web uses to communicate over the internet?
like REST and that kind of stuff?
More uh, like TCP,
Oh,
SSH, that kind of stuff.
so HTTPS.
Mm-hmm.
What protocol? Like TCP? Or I'm so so what kinds of protocols are we talking about here? Like,
Any kind, as long as they're a protocol. So TCP is a suite of protocols.
oh, okay.
And
So HTTP.
HTTP is one of the protocols within
FTP. As you said, SSH. Telnet, is that one? Or
Telnet, not sure. I'll look that up. All right, let's move on. And what are some web vulnerabilities out there for a application?
DDoS. Okay, so that's when the app is so-called jammed, when you have like multiple, when you overflood the app with multiple requests, so that it can't actually respond to anything else. Vulnerabilities, like malicious attacks, or are we talking about just failures?
Either one.
Other malicious attacks.
What would a security engineer look out for?
Depends on what the app is, but maybe injection of some sort, which is, so for example, SQL injections. So basically, you would modify the input so that it looks like another SQL command, and that might be to, and that would be a way to write, to modify the data in unintended ways.
Okay.
Other vulnerabilities. Sniffing. So if you use an unsecure web protocol, such as HTTP, your data is not encrypted and could be seen by other parties.
Okay.
Yeah.
Okay.
I'm not sure what else.
Okay. What are some new functionalities introduced in HTML5? Either API-wise or like tags, like when you write HTML.
Well, I can't think of any for HTML5, but I know CSS is it ECS6 or something? No, that's, sorry. I don't remember if that specification is for JavaScript.
Okay.
But I know they added Flexbox.
Okay.
Which is basically a different way of placing objects on the screen.
Okay. Yeah. Cool.
For HTML5,
all right, let's move on from that. In my last question, What is a DOM? A DOM.
Document object model. Is it? So this is so within in a web page, in an HTML page, you have different objects. So, for example, in an HTML, in a web page, you have multiple HTML elements, and each of these is a DOM object. Basically, these a span tag or a div tag, those are all DOM objects.
Okay. What kind of graph representation can we use for a DOM, like for an object model? Or I guess is a DOM a tree? Is it like a circular graph? Or how do they relate to each other?
So a DOM object can contain multiple DOM objects. So it would be if it was a tree, it would be a tree with multiple nodes. So I think I would actually represent it as a linked lists of linked lists of in linked lists of linked lists of linked lists, and so on. So actually a tree, a n-ary tree.
Yeah. Okay. All right. I think that wraps it up for the questions.
God, I feel like I flunked it. So for the HTTP requests, you said there were 3 components, right?
Yes.
Is that just...
Well, technically, it's like 3 different chunks that is divided
header,
into, right?
body, and what's the last one?
It's like that first line that you see in the HTTP request, which includes method, the URI, and the protocol version. So the method would be like get, URI would be the
it's post.
Like
it's
Google.com.
So the other method is post, not put.
There is also a post, but put is also one of them.
Oh, seriously?
Yep.
Okay.
Yeah. So read up on
put,
like
delete options connect. Okay. So so
there's actually 9 of them in total.
Damn. Okay, so let's see. So head okay, I'm trying to find an example here. So okay, request line. Okay, I can't.
Yeah. Let's like walk through the whole thing. Your object-oriented programming was pretty solid. You were able to explain what everything is. I think sometimes you decide to jump into an example before you define it.
Okay.
So I think if, at the very least, just say or try your best to say the definition just in one sentence before you jump into the example. Even if it doesn't make sense, your example hopefully will clear it up for your interviewer. Interface versus class, I think that was good. I would look up some cases where you would choose one over the other. So yeah, design patterns, I think that's a hit or miss, really. it's either people know exactly what it is or they have no idea. So I'd probably do some reading on just like basic ones that you use. So singletons are popular. Factory methods. I mean, I've been interviewed dependency injection, so I just put that out there. Yeah, I guess like no, maybe like 4 or 5 going in. The sequel was pretty good. I'm pretty sure, depending on where you apply, you might not even get to touch NoSQL. I've never been tested on it.
So NoSQL is scaling out, right? SQL.
Yeah, in a very abstract sense, yes.
Okay, scaling out is more associated with multiple machines, I'm guessing, right?
Yeah, I think so.
Scaling up is
it's
increasing
like
the power,
adding memory into
one single machine,
upgrading a certain machine.
Okay.
Yeah.
That makes sense.
Yeah. Yeah, look into protocols and just what they are. And then just maybe some basic vulnerability kind of issues. So SQL injection is, I think, number 1 in the OWASP, in like the top 10 this year. So it's good that you heard that. Yeah, definitely look into HTML5 because I was asked that like when I was interviewing after college.
Okay.
And there's like RESTful API versus like SOAP. I mean, that's something that pops up a lot. And let me just go through my notes. Oh, functional programming. When you mentioned that, I think that is like a discipline of programming, but not a design pattern of programming.
Okay.
You know what I mean?
Yeah.
Yeah. So they're within functional programming. People have their own patterns.
What are some examples you would give of design patterns?
So there's singleton, which is the one we use. Singleton. It's like if you want like a static, a single instance of an object that is accessible globally. That's what a singleton is used for.
Okay. So singleton is actually just a static thing.
Yeah, it's like a global static reference, just chilling there in the corner. It's good for like configuration files or log files if you want to just say, "Oh, put this in the log."
So if you
only have one log, so that's where someone would use a singleton. A factory method is I think it's a static class that depending on your input returns instances of its children. So it's kind of like you're letting users choose what children of this type, this parent object type returns. So say you have a car and you have like Mercedes and you have Benz, right? The factory method would be like, oh, get car type Mercedes, and it'll return a car, but the car is of Mercedes type. So yeah, it's like used with polymorphism. Asynchronous programming, I'm not too too familiar with it, so I haven't read up to there. I just kind of wanted to ask you about it. And yeah. So if you're applying to like more web companies, I would just do some research on the web part. And this is something that the book doesn't cover, which is why I asked today.
Okay.
Okay. Yeah.
All right. Thanks a lot, Sean.
Yeah.
I guess.
No problem.
Yeah.
Right.
Thanks for joining us, everyone. Hope. Yeah. Thanks for joining us. Bye.
See you guys.